Anyway, so I'm senior security advisor, and I spent last 25 years in IT industry, working closely with different companies. Since for most of my life I was a contractor, and approximately 10 years ago I decided to switch countries. Pardon?
Can you tell me that you want to be on camera?
Oh, okay.
Sorry.
So 10 years ago I switched countries and decided to land in Australia. And what I found is that Australian IT landscape is quite different from what I was used to. In Russia, it's more about engineering. And here, since I started my journey here in Australia also as a contractor, I visited lots of different places like large retail shops, banks, pharmaceutical companies. And what I noticed that although IT in all these places had brilliant people who were very passionate about what they do, I found that common denominator was that they were lacking fundamental knowledge of engineering. For example, the system engineers I was engaged with didn't know, for example, a 7-layer OCI model, or if they heard of it, they couldn't name half of the layers in that conceptual model. Or, for example, developers I was working with had no idea how operating system works or how a permission model is implemented on the file system. And what surprised me the most is that most of the software engineers didn't know the basic troubleshooting skills. I had a story when I was a contractor for one of the pharmaceutical industries companies. So there was a developer who created a module, and there was a reproducible bug, and he wasn't able to troubleshoot it. He wasn't able to find where the bug is, despite that it's reproducible. And to me, as a certified software engineer, I was certified in Russia. I would love to recertify in Australia, but Australia doesn't have a certification body for software engineers. Funny, New Zealand has such a body, so you can actually certify as an engineer in New Zealand. It just highlighted that there's just lack of engineering culture inside Australian IT. Before we start diving into the root cause of why it's so, I want to define what engineering is and who is a software engineer. According to the American Engineers Council of Professional Development, now a defunct organization, they converted to another body that certifies engineers in America. But in 1932, they defined engineering as a creative application of scientific principles to design and develop structures, or to construct it or operate the same with full cognizance of their design. I highlighted two parts of that excerpt I took from actually Wikipedia. Scientific principles are quite a simple idea around how you analyze something. So you observe something, then you come up with a hypothesis, and then you try to disprove it, and through a series of experiments. And then you analyze the results and repeat it until you are confident that a hypothesis is correct. And the full knowledge is quite important. It's often bites back engineers since they consider that they can't start work until they know everything about the system. But you always can go to extremes, so just don't. So I can define software engineer as a person who applies scientific principles to every single stage of software lifecycle, starting from development and ending with maintenance of that software. And they should do it with full knowledge of the design of software they operate or develop. So, software engineering as a discipline is quite young. The term was coined by Margaret Hamilton in late 60s. She was the lead software developer at MIT Labs and was working on Apollo missions. She was quite a unique person, so if you have free time after the session, just look her up. She's still alive, runs a business. She was a single mother at the time, and she was bringing her daughter Lauren to MIT labs in the evenings and over the weekends. And while her daughter was sleeping on the floor, she was creating routines which will be the soul of control module computer for Apollo. And there's a funny story around it. One of such evenings, Lauren, the daughter of Margaret, was playing on Apollo simulator, which was kind of mid-flight. And she pressed a pre-launch program, a button that triggered a pre-launch sequence. And this crashed the simulator. And Margaret spotted that and tried to escalate the issue to her superiors, but NASA declined to apply any changes, saying that astronauts are trained to be perfect and they don't do any mistakes. And you also need to understand that at that time in the 60s, they were doing quite funny stuff. Margaret was creating logic, put that logic in punch cards. These punch cards were shipped to a facility where people will hardwire them. The term came from that. So it was a series of rings, and copper wire was going through rings or over them. When it was going through a ring, it was 1, and when it was going over, it was 0. So if you spotted any mistake, the whole logic board should be thrown away and rewired. And this is where we got that term, something is hardwired in the program. So she wasn't able to change the program, but being a proper engineer, she did at least what she could do. She added a note to the user manual for NASA astronauts, so they do not press that button. Apollo 8, 5 days into the mission, around Christmas time, and the astronaut, his name was Jim Lowell, accidentally pushed that button during the flight. And it wiped out the whole navigation data from operating memory. And it meant that Apollo couldn't return back home. So it didn't know how to fly back. And Margaret and a team of coders from MIT labs spent 9 hours dissecting everything they put into that computer to figure out how to recover and how to return the team back. And they were successful, but it just, I think it kind of gave her perspective, and the company she organized after she left MIT lab, it's called Hamilton Industries Incorporated. You can look it up. Their website is so 80s. The primary focus of the company started to be create error-free software. But as with Newton's third law, which states that for each action there is equivalent and opposite reaction, a movement was born who were opposing engineering approach to software, to computing science. And one of the most famous person who were in the opposing side of that was Edgar Dijkstra. He was a Dutch scientist, academics, developer, and he has like 20 other titles. You may know him. He's most famous for coining the phrase structured programming. If you ever used in an argument structured programming, this is the guy who invented it. And he also gave Walt a numerous number of algorithms, including, for example, short pass algorithm or smooth sort. Unfortunately, I'm from engineering background, so I don't know a lot about this guy. But I believe that there are developers who know, yeah. And it's quite fascinating. You can read up, but the point is that you may not aware, but in IT there's a long-raging battle between two different communities. And before I dive into that, I just wanted to illustrate by an example I took from a textbook. So if we approach a group of people and ask them to draw a square, a rectangle, a rhombus, and a parallelogram, some people will come up with something like that, while others will draw something like this. On the right side, we have a typical example of how the person understands how shapes work and can come up with an example of each class. On the left hand side, we can see that individual can abstract of shapes and their relationship and come up with a specific case which address all the conditions. So the battle between two communities are between engineers and craftsmen. On the slide behind me, I collected some traits of both. For example, for engineers, it's being more strategic and providing strategic solutions, engage high level of abstraction and generalization, and leverage experience, patterns, and best practices from the industry. Craftsmen, on the other hand, they usually employ out-of-the-box thinking, ad hoc tactical solutions. They are very, very efficient at what they do. They leverage their personal experience and the experience of their peers and usually focus on the outcome. But the bottom line is that engineer delivers value over time and craftsmen deliver value immediately. So let's see how methodology aligns with that craftsman and engineer thing. So it all started with waterfall, so hated by craftsmen. But the truth to be told, waterfall in its pure form was never implemented anywhere. It was invented, if I recall correctly, in the Department of Defense, but it was never implemented the way how it was defined. But the modified versions of waterfall are representing the hardcore engineering, and it's something that is used in construction industry, for example. Software engineers were searching for a better methodology to address the way how they work, and they come up with prototyping. Just think about minimum viable product as a methodology, how you can create a product by approximation. Then somebody decided to merge two of them, and the spiral was born. It's kind of prototyping using waterfall. At some point in time, the opposite camp gathered their resource, and by 2001, they came up with Agile Manifesto. Followed quickly by Manifesto of Software Craftsmanship. It was in 2008, I believe. But life made some changes, and people came up with numerous hybrid solutions, something plus Agile, and implemented it that way. But it doesn't really matter which methodology you use or whether you are aligned with craftsmanship camp or engineering one. For those of you who were wondering what the last one icon is representing, its pure intuition as a methodology. So why I'm saying that it doesn't really matter? Since I do not consider that there should be us versus them mentality. I strongly believe that engineering should complement craftsmanship and vice versa, and business should leverage both to be successful. And speaking of business, if we compare business and IT from the point of industries, business is an industry and IT is an industry. If you recall, during morning sessions, we had these graphs of life cycles. Industries are also going through life cycles with four distinctive stages. It's introduction, growth, maturity, and decline. Business had 1,000 years to mature. The first businessman was a caveman who figured out that he can exchange surplus of his food to something more valuable. So business got a very strong foundation. And when you have a strong foundation, you actually don't think about it. You try to move forward. For example, it's the same like with walking. When you're a kid, running and walking requires quite an effort, especially when you're 1 or 2 years old. But when you're an adult, you don't think where you put your feet. You just walk, and you focus on other things. And to be able not to fall off to that next stage called decline, business need to find some way how to prolong that maturity stage. One of the ways, one of the approaches how you can do it is to improve management efficiency and be more agile. Basically, agile is what keeps you competitive. If you look at IT, on the other hand, it's a very young industry. It was formed in 1945. There was a first node that was mentioning information technology. I think it was the 30th of June, 1945. It's still in its growth stage of maturity. And at this point, it just doesn't require that accelerated agility. Business drives almost everything towards their model. But the problem is that everything in business except for IT is operating in real life and complies to the same mechanics and laws, mostly. And IT is half here, half in virtual world, and doesn't require that accelerated agility. You can see manifestation of that when product managers are pushing tech people to deliver something faster and cut corners just to deliver. So I think we need to solve it from two ends. Here I'm going to present only one technical solution to the problem. So business usually relies on the estimates provided by IT. Before they come up with an idea of a product, they will approach IT, and before they put the roadmap, they will ask for estimates. So what we can do, we can learn to under-promise and over-deliver. Under this, under this, I mean that when business asks you for an estimate, come up with a number, write it down, and report back something, this number multiplied by 3. But put your internal deadline to the number you kind of come up with. Most likely, you will fail to deliver proper deliverable by the official estimate you gave to the business. But with time, you will get much better, and you will be able to deliver good enough version by the time of the internal deadline. So you will have time between your internal deadline and official one to actually work on all shortcuts and compromise you made to make this good enough version. And this work can be interrupted at any moment. So when business approaches you and says, we really need to release it tomorrow, you'll be able to do it. Now that we got that time, we can, since I'm running out of time and I have lots of things to say, so now that we have time, what you can do is to contribute back to IT development as an industry. You can try to understand on which side of the spectrum you are located, whether you are a software engineer or you are more like a craftsman. It's not bad to be either, but try to learn the best traits from the opposite side. Since you'll be merging that strategic view with the tactical brilliance. Dushan, who is going to present after me, will dive much deeper into good software engineering and what it is to be a proper software engineer. But on my part, I just want to inspire you to try to always look for the root cause, even if it's just on your own time for your own good. It will make you more knowledgeable, and it will make you a master of your trade. So thank you.
You didn't do that bad, but with time, so we have time for 1 or 2 questions.
Okay.
Hi, great talk. I just had a really quick question about something you said right at the start. I'm not sure if people have seen, but Engineers Australia appear to have started advertising in Victoria, at least, for a campaign so that people can't call themselves engineers unless they're so accredited by Engineers Australia. So obviously they accredit people like mechanical engineers, but they don't accredit software engineers in Australia. I'm just wondering if you have opinions on that, given your comments right at the start.
Yeah, the thing is that I do not truly believe in certifications, since it's just a tick box exercise, unless it's supported by the industry and there are rules and code of ethics and stuff. But as far as I know, we don't have certification for software engineers yet. Yeah, I'm not sure that I answered your question. Yeah.
Do you have one more?
So it's a question about like building quality systems and having that quality code, and it's a thing that I kind of sometimes struggle to choose when is like a good enough quality and when you are being like a craftsman versus engineer. And so when is the time to kind of it's a difficult question, and I think it comes from experience, but what are your thoughts on when is like a good enough?
I think I answered it in my presentation, but I will try to reiterate. The thing is that when you approach business drives everything, and I actually dropped a big chunk of my presentation since I was running out of time. Business drives everything. They pay for whatever you do. They have a list of requirements, and good enough is when you actually delivered these requirements. It won't be perfect from engineering point of view, or as a craftsman you want perfection, but it won't be enough. It won't be perfect in this stage, but it will be enough for business to sell it, to use it and stuff. The time between internal deadline and official deadline is the time when you can actually commit to make it much better and satisfy your inner ego and train yourself and do something wonderful. But business comes first. So the moment they approach you and say, is it ready yet? This is the time you say yes.
Do you want one more? Yep, there we go. We're actually doing well with time, so we can enjoy the questions.
I'm not sure if I was reading recently some research on the idea that it's useful for productivity to separate deadlines from estimates and not use the same number for both. Have you looked in? Have you heard stuff about that? Or
I think that I'm not competent enough to answer that question,
okay.
since I subscribed to that product training we have like in several days from now. Since I'm still learning on the product side, I have a very good technical experience and knowledge. But when it comes to business part, I'm still kind of a junior. I'm learning. So I can't comment on this one properly.
So back on to Alex's questions before. So you mentioned that when kind of product is ready to use it and until the actual internal deadline. So I'm wondering, like, when business know that it's ready to be used, then they're gonna come up with the next piece of requirement slamming on, right?
Yeah.
And allowing engineer to have time to do proper engineering.
This is why you allocate 3 times more as the official deadline.
Also, how much of it is gold plating? So when to know when to stop?
Well, it's kind of a generic advice. I believe that it's on case-by-case basis, and the better you are with estimates, the better you can actually estimate how quickly you can deliver something that is good enough versus how much you need to accommodate for unforeseen. So usually when I was 20 and somebody asked me, can you create this? I will say yes. They ask, how long will it take? I'll say 3 days. And at that moment, I just saw that happy path that I will just sit down, smash it, and deliver it. But I didn't accommodate for, I want to sleep, I want to eat. Suddenly my kid is sick, or something happened and the CI I was working on breaks. I wasn't accounting for any of this. And when 3 days passed, and the person who asked approached me and said, is it ready? I said, well, I'm kind of half through it. And they were quite unhappy since there are other kind of agreements between other parts of the business I'm not aware of, and I'm kind of violating this. So for this reason, I encourage you to try to be more pessimistic about your estimate. And eventually, over the time, you will learn how to make proper estimates better and better.
Excellent. Thank you so much, Dimitri. Let's give